question that Dr. Piper set for us. It states, an 18-year-old arrives at the emergency room in a largely incoherent state with evidence of substance intoxication. His friend states he had taken drugs 4 hours earlier, and blood analysis reveals 5 milligrams per litre of the narcotic in his blood. And we're told to assume that the volume of distribution is 40 litres and the half-life of that particular drug is 2 hours. How much drug did this guy take? So, I think it's useful to think about this in terms of literally just drawing it. That's what helped me understand this. So I thought like, okay, this is the guy. He's taken some drugs early, okay? Really happy. I don't know what he's taken. Just, I don't know, just say he's like snorted something like that. And then he gets ill, right? This guy's going to get ill. It might be a guilt. I don't know. But let's say he gets ill. He's taken to the hospital here. This is the guy, he's been taken to the hospital. And so between him taking the drugs and then getting to the hospital, it's been 4 hours. Right. Blood analysis shows that there is a concentration of this drug of 5 milligrams per litre. Okay, so what do we know so far? Well, we are also told that its volume of distribution is 40 litres. So this to me indicates that actually this has gone all throughout the guy's body, right? It's taken up, it has a volume of distribution where it's actually permeated throughout the total body water. So it's gone everywhere, right? All right, so you need to think about basically this kind of sort of graph situation that's going on. So imagine this is our time here, and this is plasma concentration. And of course, it's going to go down like this, presuming it's first order kinetics. And we are already told that it has a half-life of 2 hours. And the guy has arrived at the hospital and it's been 4 hours since he's taken it. So for me, I say, okay, so maybe like halfway, the plasma concentration at the first half-life, so that's 2 hours, has gone down by half. And we know that this, we know after 4 hours, so that's 2 half-lives, that the plasma concentration here is actually 5, right? Because we've already said, when we look at his blood, it's 5 milligrams per litre of that particular drug, and it's been 4 hours since he's taken it, so we can say 5. So that means, you know, the first half-life then is going to be what? Just twice as much, okay? Because it's just twice as much, so 10. And this is so that's after the first half-life. So after 2 hours of him taking the drug, there's 10 milligrams per litre in his blood. So how much does he take initially? Well, it's just 2 hours prior again, and that's actually just going to be twice as much as this, right? Because by definition, the half-life is the time taken for the concentration to halve. So it's 20, okay? The amount of the concentration, his plasma concentration, would have been 20. So now we have this new piece of information where we can say actually that when using the equation volume of distribution is equal to the dosage over the plasma concentration, and we now know this new plasma concentration, this initial plasma concentration is 20. So we can just rearrange for the dosage to find out how much he had taken initially and say dosage is equal to the volume of distribution times by the plasma concentration. So our volume of distribution is 40 and our new plasma concentration is 20 that we've already worked out quite logically. So that's going to be equal to 800, and the units are what? Well, we were working with milligrams in terms of the concentration, so he has taken 800 milligrams.